Hello everyone, and in this video I want to practice writing a flatten dictionary function. This function takes a regular Python dictionary and creates a flat version of that dictionary. So let's just run this function and see what the result is going to be. So we have a regular dictionary, D, and this is a nested dictionary, so it has keys that are flat like user 0, and it has keys that are not flat, meaning that they have another dictionary as their value. So user 1 and user 2 are examples of such keys. Similar contact within the user 1 dictionary is a dictionary itself, but there are keys within the user 1 dictionary that are flat, like a name and age. So let's call the function and return it into a variable called flat_d, and let's iterate over the key value pairs of the flattened dictionary, and let's just print the key value pairs. Let's just see what this does. Okay, so let's just clear the screen and run our script. Okay, so this version is the flat version. Okay, and now a flat version by definition does not have any nested dictionaries. Okay, it's not a nested dictionary. So for the first key it has user 0 and person 1. This is a flat key. But for the second key, user 1 name is separated by a separator, a dot, user1.name, until we hit a flat key, and the value of that is Alice, right? User1 contact email, user1 contact email, and it does this for all of the keys within the original dictionary, right? So the function is this one, and I encountered this function upon my looking at the Netbox source code. This function is within the utilities application and data py file, and this is the definition of that function. I've tried to write this function on my own, but the version in the source code is a lot better. I'm just going to delete this and we're just going to start writing it out. So let's just define a flattened dictionary. Let's send as input our dictionary. Just start slow and evolve the code as we go. Let's just define a result and just return it. Let's see if this code works. Yes, it does. So let's go to the next step. The trick in creating this function is to use recursion. And what we have to do is we have to iterate over the key value pairs of the input dictionary. And for every key that is not a dictionary, we just have to insert that key and value pair within our result dictionary without any changes. That is the stop condition for the recursion. But if the value is a dictionary, we just have to recursively call the flatten dict function and send in the new dictionary and let it go down until it reaches a key that is not a dictionary or a flat key. So this is a perfect example of recursion because it has both the condition for a recursive function, the recursive part, and the stop condition. So let's first try to write the stop condition, and let's just iterate over our key value pairs. And if, let's just say, if type of v is a dictionary, let's just pass, and let's just do nothing about that for now. And if it's not a dictionary, meaning that it's a flat value, string or an integer or even a list, we just have to update our result with that key value pair. So let's just call this function now and see what it returns. Obviously it just returns the first key because that's the only key within the original dictionary that has a flat value. Now for the other keys, we just have to update the resultant dictionary by calling the flatten dict function and pass in the value as dictionary, the value which is a dictionary of itself. Now, there is this concept of joining the keys down the hierarchy, so we have to basically pass in the key, the current key that we have, so that the flattened dictionary on this next recursive call is able to construct that key. So to do that, let's first just define a previous keys argument to the function, and that's going to be an empty string on an initial call, and later through the other recursive calls this parameter is available to us to update. And let's just also pass in a separator which is a dot by default. Okay, to be consistent, we want to create a key that we can use both when there is a previous key or there are previous keys and when there is no previous key. So let's just write the condition of joining these previous keys if we have them with our current key, if previous keys, and if the previous key is an empty string, then we use the current key. Okay, now that we have this key, we can pass it into the next recursive call, and we can just say previous keys is equal to key, and the separator we just pass in the separator. Now the only thing we have to do is to update this k value, which is our current key iteration, and that is essentially the same as key if there are no previous keys. Okay, so key. Just updated this key here. Okay, so let's just now call the function. There is something wrong here. Let's just see. Oh, we didn't save it. Okay, and that is our resultant dictionary. This is a pretty, in my opinion, good utility function to have handy to translate between domains that require a Python dictionary to be processed in the backend. For example, you have a web server that keeps track of the records of a hierarchy using a nested dictionary, but on, for example, maybe your UI side or your REST side, you have you cannot support that nested dictionary logic and have to separate out the key values using a like a path notation, right? So this is a really useful utility function for that. You can change the separator or pass in the separator as whatever you want. So let's just use the slash here, and let's just clear the screen and run the function again, and this time the keys to the nested dictionary are separated with a slash. Okay, and yeah, as I mentioned, the original code is part of the Netbox. I think this is going to be pretty useful. Yeah, thank you very much for tuning in, and see you in the next one.